Okay, 2.3, the division of monomials. So we're now looking at the division side of the instead of the multiplication side like our last lesson. So the goal here is to use division rules to divide monomials. The quotient of two factors is found by dividing the first by the second. The result is an algebraic fraction. This is what we've been doing with fractions all this time. Okay, but now we're going to look at dividing algebraic expressions. And when we do the division of algebraic expressions, we can cancel common factors in exactly the same way as for numerical fractions. So what does that look like? So let's look at simplifying something that looks like this. It's a monomial on the top, a monomial on the bottom. It's just so fractions that like we've done before. Now just have these variables in there, x and x cubed over x. So when we divide an x cubed over x, okay, it's just like the quotient rule. Remember, there's an invisible 1, and I just subtract their exponents. So 3 minus 1 is 2. So you rewrite the base x, you write your exponent 2, and you're taking care of the variable part, okay? And 6 divided by 3, you take care of that just like you would with any other fraction. You just reduce it, so 6 over 3, 6 divided by 3 is 2, okay? Or I divide the top and the bottom by 3. Now, and that's all there is to it. And this is the end result, 2x squared. Okay. There are other ways of doing this as well. So, I mean, if you imagine 6 x times x times x, this is x cubed, right? So x times x times x is x cubed. And on the bottom, I have 3 times x. I can simply make a cancellation. So x and x cancel each other out. And I'm left with 2 x's. So x times x is x squared. And if I cancel out the 3 from the top and the bottom, this becomes a 2. So I have here 2x squared. So same answer, same result, just different ways of looking at it. Okay, let's look at another one. 4x to the exponent 4 times 12 over 12x exponent 5. So same idea. You can look at this by going, okay, 4 over 12, and I have 4 x's on the top, and I have 5 x's in the bottom. And can I make some reductions here and cancellations? I sure can. If I reduce the top and bottom by 4, then this becomes a 3 on the bottom. Okay, x cancels with x cancels with x cancels with x, each from one from the top and one from the bottom. And I'm left with just a single x. So my end results here would be 1 over 3 x. Okay, and yeah, when I cancel this, becomes a 1. Now, that's really a long way of looking at it. The simple way of looking at it is just, reduce, take your original question and reduce the fraction. 4 over 12 becomes reduced to 1 over 3. And let me just rewrite this. So 1 over 3. And I have here the quotient rule. Remember, just subtract the exponents, 4 minus 5. And that leaves me with 1 over 3 times x to the power of negative 1. And remember, I don't want negative exponents, so what you have to do is take the reciprocal of the base. And what that means is you just rewrite the x as a fraction, x over 1 to the power of negative 1, and then just flip the base. Don't touch the fraction 1 over 3, just flip the x, the base in the bracket. So 1 over 3 times 1 over x to the power of positive 1, and I don't need the positive 1 anymore, so I'll just say, so 1 times 1, up here I'm just going to do 1 times 1, which is just 1, and on the bottom I have 3 times x, which is just 3x. Same answer as what you had up here. Okay. Now, I mean, this other way might look much longer. Well, why are you doing it this way? It looks much longer or more confusing, perhaps. But as if you get used to doing it this way, then you'll be able to do more complex problems. Because doing it this way, if you have higher exponents, you're just going to be writing x forever and ever and ever. Same with the bottom. If you had a higher exponent, then you'd be writing x and x forever and doing these cancellations. So be very mindful of that. Part C. Okay, here's something a little bit more complicated. So let's see what kind of reductions we have. So I can reduce 8 and 4 become 2. Okay. So here I have the coefficients. So negative 2 times 2 is negative 4. Okay. Product rule on the top. So u times u squared is u cubed v cubed times v squared is v to the power exponent 5. And on the bottom, power of a power law, so u squared, so I have u squared on the bottom, and v squared to the power of 2, so you multiply the exponents, so power raised to a power, 2 times 2 is 4, so v to the exponent 4. Okay, and dividing these, just simplify now using your rules, so negative 4 stays negative 4. And u cubed over u squared is just a u. Subtract their exponents, 3 minus 2 is 1. I don't write the 1, I just leave it as an invisible 1. And then I have v to the exponent 5 minus, divided by v to the exponent 4, subtract their exponents, 5 minus 4 is 1. So u times v. All right. And then that eliminates our denominators. No more denominator. You just rewrite the base once. So down here, I want you guys to try this. So pause the video, and I want you to try these 4 questions down below. Okay, so hopefully we had a moment to try them. Here are the results. So it's going to go at a little bit of a faster pace. So negative 25 divided by 5 is negative 5. A to the exponent 4 divided by a is just a cubed. B to the exponent 6 divided by b to the exponent 4, subtract their exponents as part of the quotient rule, b to the exponent 2. C to the exponent 12 divided by c to the exponent 8 is just c to the exponent 4. Okay, next one, down here, part B. 16 over 4 gets reduced to 4. X to the exponent 6 over x gets reduced to x to the exponent 5. Y to the exponent 4 over y to the exponent 5 is y to the exponent negative 1. Z to the exponent 5 over z to the exponent 3 is z squared. I don't like negative exponents. Okay, so what you have to do is, flip the base. So x to the exponent 5, where it's as a fraction y over 1 to the exponent negative 1 times z squared. And if I flip the base, I have 4 times x to the exponent 5, 1 over y, change the exponent to a positive now, and then z squared. Now, this isn't really great form, so what I'm going to do is remove the exponent 1. I'm going to remove the brackets, so I don't need them anymore if my exponents are resolved. And I'm going to put the y in the denominator. So I'm going to write this as one big quotient. So I have 4 here on the top, x to the exponent 5 on the top, z squared on the top, but I'm going to put the y on the bottom. Okay, so you can take some shortcuts. If you ever see a y to the exponent negative 1 like this, to change it to a positive, just rewrite the entire thing as a quotient, as a fraction, and put the y on the bottom. Okay. Otherwise, you can just follow these steps here. That way, you won't really you can avoid making any mistakes. Okay, and going back up here to my other 2 questions. So negative 32 over 6. If I divide the top and the bottom by 2, I can reduce this to negative 16 over 3. M to the exponent 4 divided by m is m cubed. And then I have n by itself as such. Okay, so you can write it like this. You can also write it as negative 16m cubed n over 3. Either way is acceptable. Okay. And down here, last one, negative 3 to the exponent 4 divided by negative 3. So that's just going to be negative 3 to the exponent 3. Subtract their exponents. Same base, subtract their exponents. 4 minus 1. P squared over p just becomes p. And q to the exponent 5 divided by q to the exponent 1 becomes q to the exponent 4. Okay. And we can also go one more step further. Negative 3 to the exponent 3 is negative 27 times p times q to the exponent 4. And we're done.